Welcome back. This is the third video for Chapter 8, Writing Classes. In this video, we're going to take a look at writing classes in processing, and we're going to do that in the context of a larger example, which we'll get to in a minute. Now, before we start on our example, let's start with a little bit of basic syntax and style. And so, generally speaking, we're going to code every class that we write in a separate file. We've been used to so far having a text file that we have our program in, the PDE file, and really what we'll be doing for a class then, another class, is just having another file open at the same time, sort of like multiple tabs in a web browser or in a word processor. The nice thing about writing classes in processing is there's really only one new thing to learn, and that is the class keyword. So let's take a look at what a class might look like. Again, this would be in a separate PDE file, a separate text file from our main program. But we're going to begin with the class keyword, and then we have the name of our class and opening and closing curly brackets. So it's similar to a method, except it doesn't have a return type or parameter list. Now, stylistically, what we'll do is inside our class, up at the top, we'll declare our fields first. Then after the fields, we'll go ahead and declare our constructors. And remember that we should always have at least a default constructor, and then one or more initializing constructors. And then after the constructors, we'll have all of the other methods for the class. We'll return to the actual syntax later and actually probably get into that in the next video when we start coding up this mosh pit example. But our mosh pit is going to be our major example for the chapter, and it'll be the framework upon which we learn about how to write classes in processing. So here's our problem description. We're going to create an application with a square display window representing a God's eye view of a virtual mosh pit. We're going to fill that pit with several virtual concert goers represented by randomly colored circles. We'll start some music, and then every circle will start moving randomly. And then as the song keeps going, the level or the volume of the song will influence the speed of the concert goers. And then they will careen off of each other and off the walls on the display window. So we'll give you an example of what it should look like here.
All right, this is Oblivion.
Yeah, it is.
Now what we need to do is think about where to start. In our previous design methodology, we would start taking our problem, dividing it up into sub-methods, and working that way. But here in an object-oriented perspective, we're going to do it a little bit differently. We're going to begin by trying to identify the classes that we'll need, because the classes are going to be the focus of the design, not the methods. And a passable way to do that is to look at the problem statement and then try to identify the major nouns in that problem statement. And that will lead us to the classes that we might have to incorporate in our program. So here's a noun list from the problem statement. We have application, display window, mosh pit or just pit, concert goers, circles, music, song, direction, speed, level, and walls. Now it turns out that many of those are actually synonyms for the same concept. So let's consolidate and shrink that list down by rolling together all the things that actually mean the same thing. Okay, well, first of all, the application, display window, and mosh pit really are all the same thing. Those are synonymous with the actual application itself. So we'll roll those three nouns together into just application. Next, our concert goers and our circles really represent the same thing. And so in keeping with the mosh pit example, we'll call those elements dudes. Now our music and our song really are the same thing, and it turns out that we already have something in processing that represents music or songs, and that would be an audio player object. So we'll incorporate those two together into an existing class, and that's something different, called audio player. Now our last four elements, the direction, speed, level, and walls, we really can't incorporate any of those together, so we'll just carry them over directly. It doesn't mean that they're all going to be classes, it just means that they're distinct elements, they're not synonyms for each other. Okay, now what we're going to do is look at our noun list in one final format and try to determine which of those nouns are actually characteristics or subfields, if you will, of other nouns. So application is going to be our overall program. Which of those nouns from the second noun list would actually be fields in that application? Well, clearly there will be an audio player object that has the song in it, so that will be a field of application rather than a separate class that we have to write. And the level of the song is actually sort of a characteristic of the audio player, so we can disregard that for now. We won't worry about it until later, and we certainly don't have to write that as a separate class. And our walls are also an aspect of the application, just like the walls in the Solopong example were part of that application. So the walls won't be a separate class, rather they'll be some characteristic or aspect of the application, the program that we're writing. Now the other major class that we will have to write is the dude class. So which of those nouns from the previous list are actually characteristics of the dude? Well, speed and direction. So those two elements from our noun list are actually characteristics of our dude rather than separate classes. So based on all this, we're going to have two separate classes that we're going to write. The first one is our application class, okay? And that will be a processing program, just like the other programs that we've written so far, with setup, draw, etc. And then the new aspect will be our dude class that contains all the information about one of our virtual concert goers. Speed, direction, color, the ability to bounce off things, all that. So as a next step, what we're going to do is take a look at those classes and identify the fields and the interfaces that we need to have for that class. So what are the pieces of data that go in that class, and what are the interface methods that go in that class? Okay? And really the only class that we're going to be worried about is our dude class. So the dude is what we have to design next. Well, here's a first take at the fields that we might require in our dude class. And if you think about Solopong, the example from chapter 6, a lot of this should be familiar, and what's different is that we're incorporating this inside the dude rather than in our main program. So we'll have a maximum speed that the dudes can move per frame. We'll have a radius so that all the dudes will be the same size. So those two will be constants. And then we'll have some different variables that can change between dudes. We'll have the color, so each dude can be a different color. We'll have their maximum speed that they can move, and that will vary depending on the level of the song that's playing. We'll have their X and Y location, okay, so that's just like Solopong. And also, just like Solopong, we'll have a dx and dy variable that represent their actual speed in each of those directions. Now let's take a look at our interface. So that would be these methods down here. These are the ways that we're going to interact with our dude object. Okay? So previously we had drawn a class like this as a box, and our interface methods are represented by these boxes that are half in and half out of the class. Those are like the buttons that we poke to make this dude do things. Okay? So we have a default constructor for our dude. This one won't require an initializing constructor. Every dude will know how to draw itself. We'll have getX and getY methods so that we can always tell the location of the dude. We'll have two methods for handling collisions with other dudes and handling collisions with the wall. We'll have the ability to set the max speed to a certain value, and we'll have our update dude, which will make the dude move. Okay, so those will be methods that can be called from the outside. Now, quite often, our classes will also have other methods that aren't intended to be called by users of the class, and those are what we might term to be helper methods, ones that are sort of hidden behind the scenes and just designed to make the workings of the class go smoothly. Not intended to be called from the outside, but used internally to make things work correctly. So in this case, we're really only going to have one helper method, and that will be one to change its direction and speed. And so that would be a method called after we run into something, either the wall or another dude, and what we'll do is change our direction and the speed that we're moving at in a random way. Okay, so that never needs to be called from the outside. Rather, it'll be called from the constructor probably, or from the handle collision methods. And so since it's called only from methods that are already inside the dude class, that's a helper method. Now, it's important to remember that design is an iterative process. So it's going to go around in a circle for a while until we're ultimately satisfied that we've found a design that works. Those UML class diagrams with all the fields and the methods didn't spring up in their entirety right away. Rather, it was an iterative process where we would go back and forth and think about things and ultimately refine until we come to a design that we like. So don't get discouraged if you can't design everything on the first try, but get something on paper, think about it a bit, maybe even write a little bit of code, but then as you alter things, go back, change your design, adapt your code, and repeat the process. What you don't want to do is jump right into coding without doing any design first. Okay, now our next step in the design process will be to design the methods in the class using our familiar tools. And so that would be pseudocode or maybe even a flowchart if the methods happen to be very simple. So what we're going to do is take a look at two of the methods in the dude class. We will leave the collisions method alone because it's very similar to the collision detection that we had in Solopong. You can see that in the textbook. But we will focus on the constructor and then one other method. So when we create one of these objects, the first two things we're going to do is to choose a random location for our dude. Okay? And so this gives us a range that's entirely within the walls of the mosh pit. Then we're going to set their max speed to the default max speed value. Then we're going to call that change direction and speed helper method, and what that will do is simply apply random values to dx and dy to give it an initial motion, and then finally we'll assign some random color to the dude. And the last thing we're going to do is look at handling collisions with other dudes, because again this is a little bit different from what we did in Solopong. But what we're trying to figure out is the distance between two circles. So we're going to look at their center points, determine this distance here, and if that distance is smaller than the distance between two circles that are just contacting each other, then we'll know that they've collided, and in that case we will return true. Or not return true, but rather change our direction and speed. Okay? So the first thing we're going to do is determine our delta x and delta y, find our distance using a distance formula where we take the square root of the sum of the squares of those deltas, and then we ask if that distance is less than twice a radius. That means that they have collided, and in that instance we'll change our speed randomly and the other dude will also change his or her speed randomly, and that way we'll bounce off each other. Okay, so now we are leaving out the collision methods for the walls, but those are very similar to what we did in solo Pong. Okay, in our next video then we're going to look at our application class, that is with the setup method, draw, etc. Talk a little bit about audio, how we can determine the levels, and then look at some coding.